Welcome back to the Deep Dive. It is Saturday, February 28th, 2026, and I have to say, looking at the calendar, it feels like we are living in a completely different timeline than we were just a few years ago.
It really does. I was just reviewing this stack of research for this week, and the sheer velocity of change is, well, it's disorienting.
Disorienting is the exact right word. I was looking at our sources for today, and we have a massive stack, by the way. Everything from heavy hardware specs to labor market analysis, and I had this sudden flashback. Do you remember late 2023, maybe early 2024?
Oh, yeah, the chatbot era.
Exactly, the chatbot era. We were all completely losing our minds because a computer could write a haiku or generate a picture of a cat in a spacesuit.
Yeah.
It felt like absolute magic at the time.
It did, but looking at the reality of 2026, that period feels like, I don't know, playing with wooden blocks.
Yeah.
It was the novelty phase. It was the look what this cool toy can do phase. But what we are seeing in the data today in February 2026 is that the toy box is firmly closed. We have moved into what the industry is now calling the era of industrial scale agency.
Industrial scale agency. That sounds heavy. Sounds like heavy machinery on a factory floor.
That is exactly the point. We aren't really talking about generative AI anymore. Honestly, if you hear someone pitching a generative AI strategy in 2026, they are already 2 years behind the curve.
Because we aren't just generating text or images to look at.
Right. We are talking about agentic AI. Systems that reason, systems that plan, and crucially, systems that execute multi-step workflows without a human hovering over their shoulder every 2 seconds.
And that is the core shift we need to unpack today for you, the listener.
Yeah.
Because I think a lot of people are still stuck in that 2024 mindset.
Yeah, absolutely are.
They think AI is a thing you chat with, you type a prompt, you get an answer. But the research we have here says that is basically the horseless carriage version of the technology.
Precisely. If you are still using AI just to write emails or summarize a PDF, you are using a supercomputer as a typewriter.
A typewriter, wow.
It's true. The sources we have today are going to show us how the entire infrastructure, from the silicon chips to the boardroom strategy, has been completely rebuilt to support agents that work for you, not just with you.
We are going to cover a lot of ground today. We will look at the death of the one model to rule them all mentality, which I think is a huge relief to see in the report.
Yeah, absolutely. It democratizes the whole field.
We are also going to talk about this fascinating new career path called vibe coding.
I love that term.
It sounds totally ridiculous, I know. But the reports highlight it as the most important shift in software engineering in decades.
It is. It really is.
We'll get to that. We're also going to look at the hardware, specifically what NVIDIA is doing with the Rubin platform, which is just the numbers are silly. And we will look at the real-world adoption in the Fortune 500. Because, and correct me if I'm wrong here, looking at these reports, the era of pilots is essentially over.
Pilot purgatory is largely over for the winners. The companies that are winning right now are in full production. They aren't experimenting in a sandbox anymore. They are balancing their books with this stuff.
So let's start where the rubber meets the road, or rather where the electricity meets the silicon, the engine room.
Let's do it.
Because none of the software magic happens without the hardware to back it up. I was looking at the financial reports in our stack, specifically regarding the CapEx supercycle, and there was a number here that frankly looks like a typo to me.
It is not a typo, but it is a massive gamble.
$400 billion.
Yeah.
That is the estimated capital expenditure driven by the hyperscalers, Amazon, Microsoft, Google, Meta, in this cycle alone. $400 billion.
It is a staggering amount of capital. To put that in perspective for you, that is larger than the GDP of many mid-sized nations. And you really have to ask yourself why. Why are they spending this? It isn't just to keep Gmail running a few milliseconds faster.
Right. If this was just about maintaining the status quo, the shareholders would be revolting in the streets.
Exactly. This is an architectural reckoning. They are entirely rebuilding the internet's basement. They are betting that compute is going to be the oil of the next decade, and they are building their refineries right now.
But the really interesting metric in these reports isn't the total spend. It is the unit economics.
The cost of doing business.
The cost of inference. For you listening, inference is just the technical term for the AI actually doing the work. When you ask a question and it generates an answer, that is inference.
Right. And between late 2022 and late 2024, the cost of inference dropped 280-fold.
280-fold. That is essentially a complete collapse in price.
And it just kept dropping through 2025. This is the single most important economic fact in AI right now, because when something becomes that incredibly cheap, you stop rationing it.
Meaning Back in, say, 2023, if I asked GPT-4 to do something, it cost the company a few cents. They didn't really want me doing it 1,000 times a day.
Exactly. It was a
A
consultant.
consultant.
Yeah. You hire a consultant for a specific high-value task because they are expensive. You bring them in, ask the important question, and send them away. But when the cost drops 280-fold, the AI goes from being a consultant to being an intern. Or even just electricity.
You just leave it running.
You leave it running. This is why agentic AI is even possible now. You can have an agent running in the background for 24 hours straight, constantly checking your supply chain, looping on a complex reasoning task, and it doesn't bankrupt the company to do it.
So the hardware enabled the economics, and the economics enabled the new behavior.
Spot on. And the hardware that is truly driving this in 2026 is the NVIDIA Rubin platform, launched at CES back in January.
The Vera Rubin platform,
Right.
named after the astronomer who discovered dark matter, which is a nice poetic touch considering how much hidden value they claim this platform is unlocking.
It is very fitting, but the specs are what really matter here, and this is where we see a total paradigm shift.
How so?
For the last few years, we have been obsessed with the chip. The H100, the Blackwell, we talked about them like they were car engines. How fast is the chip?
Right. I have the new B200. It's faster than yours.
Exactly. But Rubin isn't a chip. It is a platform. It is a rack-scale supercomputer. NVIDIA realized that making the individual chip faster just wasn't enough anymore. They had to redesign the entire rack.
Explain rack scale to me. Because when I see a server rack, I just see a tall metal cabinet with a bunch of blinking lights.
Okay, imagine that standard server rack. In the old days, you would shove a bunch of independent computers into that cabinet. They talked to each other over cable, sure, but they were separate entities. The Rubin NVL72 connects 72 GPUs and 36 CPUs so tightly that the software actually thinks it is one single massive brain.
So it isn't 72 computers talking to each other. It is one computer with 72 hearts.
Essentially, yes. It acts as one unit with 75 terabytes of incredibly fast memory, and it delivers 50 petaflops of inference performance.
50 petaflops.
That is 5 times the performance of the previous architecture, Blackwell, which was already an absolute beast of a machine.
5 times faster in one single generation. But I want to drill down on something you mentioned just now, the memory.
Yeah.
Because the report spends a lot of time talking about solving the memory wall.
Yes, the memory wall. It is the absolute bane of AI engineers everywhere.
I feel like we hear about bottlenecks all the time in tech, but what is the memory wall physically? Like in plain English?
Okay, think of it this way. Imagine you are a world-class chef.
Okay, I'm a chef.
You can chop an onion in a millisecond. You are incredibly, inhumanly fast. That is the GPU, the processor.
Got it.
But your pantry, where the actual onions are stored, is 3 miles down the road.
Oh, so it doesn't matter how fast I chop. I am spending all my day driving back and forth to the pantry.
Exactly. That is the memory wall. The processor chips got so fast that they spent all their time just waiting for data to arrive from the memory chips.
The driving time.
Right. And with these new massive models we're using today, the mixture of experts models that act like huge, sprawling encyclopedias, the chef needs to run to the pantry constantly to grab different recipe books. It creates a massive traffic jam.
So what is NVIDIA's solution? Moving the pantry closer.
They essentially put the pantry directly on the cutting board.
Wow.
The Rubin platform uses something called HBM4 memory high bandwidth memory and a new component called the Bluefield 4 storage processor. Together, they move data at 22 terabytes per second.
22 terabytes per second. That number is just hard to conceptualize.
It is, but what it means practically is that it effectively eliminates the wait time. The chef is chopping nonstop. The data is just there. And that is a huge reason why inference costs are dropping so fast. You aren't paying for the waiting time anymore. The hardware is finally keeping up with the software's demands.
That makes a lot of sense. So we have the factory floor, the Rubin platform pumping out cheap, fast intelligence. Now let's talk about the workers on that floor, the models themselves.
The brains of the operation.
Right, because 2 years ago, the conversation was very monolithic. It was OpenAI versus Google, just these massive single models that did everything.
It was very much a one model to rule them all mindset.
But looking at the landscape in 2026, it is completely fractured. It looks much more like a specialized workforce.
That is the perfect way to describe it. We have moved to a heterogeneous ecosystem. You don't use the exact same model to write a creative poem that you use to audit a complex financial statement.
Let's look at the heavy hitters first, the proprietary models. I want to start with Anthropic. Claude 4.6 Opus.
The report classifies Claude 4.6 Opus as the leader right now. It is currently the absolute darling of the software engineering world.
Why is that?
Well, it has a massive context window, 1 million tokens in beta, meaning you can feed it a huge amount of information at once. But its real claim to fame is its reasoning ability in software engineering.
I saw a stat here in the stack that jumped out at me. A SWE bench score of 80.8%.
That is the number everyone in the industry is looking at.
Explain SWE bench for us.
SW Bench is a very rigorous benchmark that asks an AI to solve real-world GitHub issues, real bugs, real feature requests, inside existing complex code bases.
So it wasn't just saying, write me a simple snake game in Python.
Not at all.
Yeah.
It is saying, here is an obscure memory leak in this massive open source library that took human engineers weeks to track down. Fix it.
And 80.8% means it successfully solves 8 out of 10 of those real-world problems.
Yes. For context, back in 2024, the absolute best models in the world were struggling to hit 20 or 25% on that same benchmark.
That is a massive leap.
We have gone from an intern who needs constant supervision to a senior staff engineer in basically 2 years. If you're doing complex long-form coding tasks today, you are using Opus.
But then you have Google, Gemini 3.1 Pro. The reports paint a very different picture of their strategy.
Google has taken a totally different lane. They are classified as the multimodal leader. They have leaned heavily into deep integration with their existing ecosystem.
Right.
Gemini 3.1 Pro isn't just a text box you type into. It is deeply grounded in Google search. And it has these new thinking capabilities, what they call dynamic compute allocation.
Dynamic compute allocation. What does that mean in practice?
It means the model itself decides how much effort to spend on your prompt.
Oh, interesting.
If you ask it what is 2 plus 2, it answers instantly. It uses almost no compute. But if you ask it to analyze the geopolitical implications of a sudden drop in global lithium prices, it pauses.
It actually stops and thinks.
Literally, it allocates more compute, thinking for longer, exploring multiple logical paths internally before it finally gives you an answer.
So it knows when to focus and when to just give a quick reply.
Exactly. And because it is Google, it handles video, audio, and images completely seamlessly. If you need an AI agent to watch a 2-hour YouTube video, understand the visual context, and extract specific data points into a spreadsheet, Gemini is the clear winner there.
But what about OpenAI? GPT 5.3, they started this whole race.
They are still a massive powerhouse, of course, but their strategy has shifted heavily toward routing.
Routing, like a traffic cop.
Kind of. GPT 5.3 is a master of versatility. It is a unified system that is incredibly good at deciding when to use a simple, cheap submodel for a basic task and when to bring in the full, expensive brain for complex reasoning. It acts as the best general manager model on the market.
Okay, so those are the closed proprietary models. But here is the plot twist for me in this week's reading. The open source disruptors.
Oh, this is the most exciting part of the data.
Because I remember when Meta's Llama 2 came out a few years ago, and everyone in the tech press said, oh, it's cute, it's good for tinkerers, but it will never actually catch up to GPT-4.
Those were famous last words.
According to this data from 2026, the gap is basically gone.
It is statistical noise at this point. The performance gap between the absolute top closed models like GPT-5 and the top open weight models is now roughly 1.7%.
1.7%. That is completely imperceptible to a normal human user.
For 99% of use cases, yes, you would never know the difference. And a lot of this pressure is being driven by models like Qwen 3.5 from Alibaba.
This one really jumped out at me in the spec. Qwen, a Chinese model matching the best of Silicon Valley.
A massive Chinese model. 122 billion parameters, a massive context window of 262,000 tokens, and incredibly cheap to run about 40 cents per million tokens.
And the reports note this completely changes the geopolitical map for AI.
It really does. For a long time, the dominant narrative was that the United States has the AI, and everyone else in the world just rents it via an API key.
Right.
Qwen proves that simply isn't true anymore. High-end AI is not an American monopoly, and this is actively driving the sovereign AI trend we are seeing globally.
Sovereign AI. meaning countries wanting their own local intelligence.
Exactly. Countries are looking at Quinn and saying, wait, we don't need to depend on OpenAI or Google and send all our national data to California. We can take an open source model of equal power and run it on our own servers, completely inside our own borders.
That is a huge shift in global power dynamics.
It is. And then you have Meta in the US. Mark Zuckerberg is playing the absolute wild card here with the Llama 4 Scout.
Llama 4 Scout, the specs on this one are wild.
It is an absolute beast. A 10 million token context window.
10 million tokens.
You can feed it entire corporate archives all at once. 10 years of executive emails, entire software code bases, decades of financial reports. And because it is open weights, you can run it locally on your own hardware.
The report calls this the enterprise disruptor.
Because it is. Think about it. If you are a massive bank or a defense contractor or a healthcare provider, you legally cannot send your highly classified data to an OpenAI or Google server.
The compliance risk is just too high.
Right. But you can download Llama 4 Scout and run it in your own secure basement data center. It gives you the super brain without any of the data leak risk.
And we are also seeing super specialized models, not just these big generalists, like Nano Banana 2 from Google.
Yes, the naming conventions are still very playful.
Nano Banana 2 is specifically for data visualization and infographics, or Mistral Codestral, which is a European model purely for coding.
Mistral Codestral is fascinating because it often outperforms the massive generalist models in very specific syntax tasks, simply because it isn't cluttered with knowledge about 18th century French poetry. It only knows code.
So we have the hardware with Rubin.
Yeah.
We have this diverse workforce of model brains, Opus, Gemini, Llama, Quinn. But let's go back to that term we used at the beginning, agency.
Right.
Because having a really smart brain sitting in a jar on a server doesn't mean it can actually do a job for you.
A brain isn't an employee.
Right. So how do we actually go from a really smart chatbot to an employee that does workflows?
We have to completely change the architecture. We have to stop thinking about prompting and start thinking about agentic workflows.
What is the real difference there? For someone used to just typing a paragraph into a chat box?
The difference is reliability. There is a deeply damning statistic in our research stack today. Performance degrades by 58% in sequential reasoning loops if you don't have oversight.
Translate that for us. What does a sequential reasoning loop look like?
If you go to a chatbot and give it a vague multi-step command like, hey, plan a comprehensive marketing campaign for this new product line.
Okay.
To do that well, the model has to make about 20 distinct decisions in a row. It has to identify the audience, pick the channels, write the copy, set the budget, and so on.
Right.
By the time it gets to decision number 5 or 6, it usually forgets the context of decision number 1. It hallucinates, it drifts off topic. It is basically playing a game of telephone with itself.
The 58% degradation.
Exactly. It just falls apart.
So how do the engineers in 2026 fix that?
We treat the AI like a piece of software architecture, not like a really smart person. We use what are called agentic design patterns.
Agentic design patterns.
Think of these as the microservices of AI. We break the big job down into tiny, manageable pieces.
Break down some of these patterns for me. What is the most basic one?
The simplest one is the sequential pipeline. This is literally just an assembly line.
Okay.
You don't ask one single AI to do everything. You have Agent A. Its only job is to read an incoming customer email and extract the date they want to book an appointment.
Simple enough.
Right. Agent A passes that single piece of data to Agent B. Agent B's only job is to check the database and see if that date is available. Then Agent B passes a yes or no to Agent C, whose only job is to draft a polite reply.
So each agent only has one highly specific job.
Yes. And because the job is so small and bounded, it is incredibly hard for the model to mess it up or hallucinate. It is deterministic.
But the work gets more complex than just checking a calendar. What about the parallel fan-out pattern I see here in the notes?
Parallel fan-out is where it gets really fun.
It sounds like what I do when I am completely overwhelmed with a project.
Well, it is highly effective. Let's say you need to write a massive comprehensive investment report on a competing company. You do not ask one single agent to just write the report. You create a manager agent. And that manager agent spawns 5 specialized worker agents.
Oh, wow.
One is designated as the financial analyst. It is only allowed to look at balance sheets. One is the news analyst. It only scrapes recent press releases. One is the competitor analyst. It only looks at rival market share.
And they all work at the same time.
They all work at the exact same time, in parallel, hence the name fan-out.
And then how does it come together?
They all report their findings back to a final synthesizer agent. That agent's only job is to combine all their distinct work into one cohesive document. You get 5 deep, specialized perspectives instead of one generic, surface-level summary.
That seems so much more robust than just asking a chatbot to write a report.
It is exponentially more robust, but my absolute favorite pattern is called reflection or metacognition.
Metacognition, this is the editor concept, right?
Yes,
Yeah.
because one of the biggest inherent problems with large language models is that they are massive people pleasers.
They just want to give you an answer, any answer.
Exactly. They want to give you an answer so badly, even if that answer is completely wrong or made up. In a reflection pattern, you don't just accept the first answer. You have one agent generate a draft. Then you force a second agent, which is specifically prompted to be a harsh, unforgiving critic, to review that draft.
So the critic agent asks things like, is this citation actually real?
Yes. Is this citation real? Is this logic sound? Is the tone appropriate for a professional setting? Did you miss a negative sign in the math?
So the human user never actually sees the first draft.
No. The user only ever sees the version that has survived a rigorous argument between the generator agent and the critic agent. It forces the system to literally think twice before speaking.
Now, for any of these agents to actually work with them, to check a calendar or read a balance sheet, they need access to our stuff, our files. I saw this acronym, MCP, all of the technical reports, the Model Context Protocol.
The USB-C for AI.
That is a really bold claim to make.
Yeah.
USB-C changed everything about how we connect devices.
And MCP is doing the exact same thing for artificial intelligence right now. Here's the fundamental problem we had until very recently. Your AI agent was trapped in the web browser.
Right.
It couldn't see your local Excel file on your desktop. It couldn't query your company's proprietary SQL database securely. It was an island.
I remember that. You had to manually copy-paste data from your spreadsheet into the chat window, wait for an answer, and copy-paste it back.
Right.
Which is a total security nightmare for a real enterprise.
A nightmare. And incredibly slow. MCP is an open standard. It's actually supported by NIST's AI Agent Standards Initiative, by the way, that builds a secure bridge.
How does it work?
It allows you to create a secure, standardized port on your data. You can tell your database, hey, I speak MCP now. And now, whether you are using Claude or Gemini or Llama, the agent can plug into that port, run a secure query on the data, get the answer, and get out.
So it completely prevents ecosystem lock-in.
Yes. You aren't stuck forever in the Microsoft ecosystem or the Google ecosystem just because your data is there. Your data is independent. MCP is the basic plumbing that makes actual secure agency possible across different platforms.
So they use small language models, or SLMs, to handle the basic routing using this plumbing and save the big expensive brains for the hard reasoning.
Exactly. You don't use a massive model to check a calendar via MCP. You use a fast, cheap SLM.
It really feels like we are literally building a digital workforce from scratch. We have the brains, we have the architectural patterns, we have the communication protocols.
Grab all the pieces.
So the big question is it working? Who is actually making money from this? Because I feel like for 2 solid years, all we heard from CEOs on earnings calls was, we are piloting this technology. We are exploring use cases.
The era of pilot purgatory is ending. And this is but there is a huge divide right now. The reports call it the scaling gap.
What do the numbers actually say about adoption?
88% of organizations globally say they use AI in some capacity. But only about 30% have successfully scaled any of those pilots into actual production.
And how many are making money?
Only 5%. The reports call them the future-built firms. Only 5% are generating material, reportable value from AI.
Material value meaning it actually shows up as real money on the bottom line.
Meaning it improves the P&L statement. And the key differentiator, the thing that separates the 5% from everyone else, is that these firms are actively spending their budget on agents. Specifically, 15% of their total AI budget goes exclusively to agentic workflows.
Let's talk about the winners then. The Fortune 500 case studies in this stack. JP Morgan Chase is a huge one.
JPM is a fascinating example because they are basically fighting a war right now, a silent cybersecurity war.
The report says 16% of all cyber attacks today are now AI generated.
16%.
So the hackers out there are using agents too.
Of course they are. The bad guys have access to the exact same open source models and agentic patterns that we do. They have autonomous agents that can scan millions of IP addresses across the internet, find a 0-day vulnerability, and write a custom exploit code for it in seconds. A human security team simply cannot move fast enough to counter that.
So JPM has to fight fire with fire.
It is literally AI versus AI. JPM is using defensive agentic swarms that don't just patch holes after an attack, they predict them. They analyze massive, real-time patterns in the ledger and the network traffic, looking for the invisible fingerprint of an AI attack before it executes.
It is an arms race.
It is an arms race. But JPM is winning their battles because they fully automated the defense.
What about physical, real-world logistics? Walmart is in the reading.
This is supply chain magic right here. Walmart isn't just using AI to write cute product descriptions for their website. They are using multi-horizon neural networks to reduce their actual stockouts by 25%.
25% less empty shelves. That is huge for a retailer of that size.
It is massive revenue. But the how is the truly agentic part. The system detects a subtle demand signal. Maybe a weather event is coming in the Midwest, or a weird TikTok trend is suddenly making everyone buy cottage cheese.
Right.
The agent doesn't just send an email alert to a human supply chain manager to review on Monday morning. It autonomously reroutes the physical inventory trucks on the highway in real time. It updates the warehouse orders.
It actually moves the truck.
It reroutes the inventory. And get this, it even schedules the human retail associates in the stores.
Wait, the AI manages the human shift schedule?
Yes. The report calls it the autonomous routing of human associates. The agent analyzes the real-time data and says, okay, we have a massive surge in foot traffic in the electronics department right now. I need 3 more people there immediately. And it pings the handheld devices of the staff on the floor to move them.
That is incredibly efficient and honestly a little dystopian to think about, being actively managed minute by an algorithm.
It is the new reality of the retail floor, but the data shows it works. And speaking of physical reality and manufacturing, look at the Siemens case study.
The industrial metaverse.
Yes, the industrial metaverse, which is a term that got a lot of eye rolls a few years ago when everyone's talking about VR goggles.
I certainly rolled my eyes at it.
But Siemens is making it real and practical. They have built something called the Digital Twin Composer in partnership with NVIDIA.
Walk me through the PepsiCo example they highlight.
So PepsiCo needed to completely change a major factory production line. In the old world, the physical world, you shut down the entire factory. You unbolt and move heavy machines. You weld new pipes. Then you turn it all on and you realize, oh no, bottle A hits bottle B at this one junction.
You have to stop the line and fix it.
Right. Expensive trial and error. It costs millions of dollars in unexpected downtime.
So what do they do differently?
PepsiCo used Siemens AI agents to simulate the entire factory change in a perfect physics-based digital replica. The AI autonomously ran thousands of different layout scenarios over the weekend. It found a specific machine layout that increased the total throughput by 20%.
Wow.
And the kicker is, they didn't physically move a single box or weld a single pipe on the real factory floor until the digital simulation was verified as perfect. They saved 15% on capital expenditures.
That is pure profit right to the bottom line, just by doing the math first.
Exactly. And then, of course, we have the elephant in the room in these reports, Tesla.
Tesla and the Optimus humanoid robot.
I know, people love to debate the robot on social media, but look at the hard numbers in the enterprise report. They are deploying them in the Texas factory now, and they're targeting 1 million units per year by 2027. But here is the highly specific number that caught my eye. $57,550.
What exactly is that number measuring?
That is the estimated annual savings per replaced worker in a factory setting.
$57,000 saved per worker.
Yes. When you account for hourly wages, benefits, mandatory rest breaks, healthcare insurance, and continuous efficiency, the robot obviously costs capital up front to buy, but the operational expenditure is drastically lower over the year.
So if you have a massive factory with 10,000 human workers and you replace just 10% of them with robots, the math gets very large, very fast for the shareholders.
The economic incentive is almost impossible for a CEO to ignore, and what we are seeing across the Fortune 500 is a total shift in how AI is tracked.
Moving away from cool pilots.
Moving strictly to a profit and loss tracking model, the AI P&L, companies are employing a strict 90-day deployment plan now. Days 1 through 14 are governance and security. Days 15 to 45 are the pilot. Days 46 to 75, it goes into full production. And by day 90, they establish a center of excellence to scale it. If it doesn't show ROI in 90 days, they kill it.
That pace is relentless. Which actually brings us to the most uncomfortable part of this entire deep dive today. The human element.
The workforce disruption.
Right. Because if a humanoid robot saves a company $57,000 a year, and an AI agent can reroute global supply chains faster and better than a senior logistics manager, where exactly does that leave us, the humans?
It leaves us in a period of massive transition. The World Economic Forum statistic in the reading is sobering. They estimate 92 million jobs will be completely lost globally due to AI disruption.
92 million jobs. That is a terrifying number for anyone listening right now.
It is, but you have to look at the second half of the WEF projection. They also predict 170 million new jobs will be gained. It is a massive net positive for human employment overall.
And there is always a but with these macroeconomic numbers, are the specific people losing the 92 million jobs actually qualified for the 170 million new ones being created?
In most cases, no. That is the massive skills gap we are facing right now. And to make matters worse, there is a severe perception gap in the workforce.
The perception gap.
The surveys show that 70% of workers look at the macro trends and say, yes, AI is highly disruptive to the economy. But almost none of those same workers think their own specific job is at risk.
Right. It's always, oh, AI will definitely come for the truck drivers or the factory workers, but it won't come for me, the mid-level accountant. I'm special.
Spoiler alert for the accountant.
Yeah.
The AI is definitely coming for you. In fact, what the labor market analysts are tracking right now is something they call the sandglass effect.
The sandglass effect. Describe the shape of that for us.
Think of a traditional hourglass or sandglass. The top section is very wide.
Okay.
That represents the high-level strategic thinkers, the creative directors, the senior executives, the people who look at the board and decide what the company should do next. Those people are highly safe. Actually, their productivity is massively leveraged by AI.
So the top is safe.
Then look at the bottom of the sandglass. It is also very wide. That represents the complex, unpredictable physical trade jobs. Plumbers, electricians, ER nurses, specialized construction. A multi-million-dollar AI agent still cannot fix a leaky pipe under your sink.
So the physical bottom is safe.
Right. But what is in the middle? The neck of the hourglass. It is incredibly narrow. It is getting squeezed from both sides.
The middle class of knowledge workers.
Exactly. The mid-level specialist is the most at risk right now. The junior coder who just writes standard boilerplate functions all day. The copywriter who just churns out generic SEO blog posts. The middle manager whose only real job is routing information from the top of the company to the bottom.
The agents are taking the middle.
Yeah.
Because that work is essentially sequential reasoning and data processing.
Precisely. If your job is just taking data from column A and formatting it into column B, an agent can do it faster, cheaper, and without needing a coffee break.
So if you were listening to this right now and you realize you are sitting firmly in the neck of that sandglass, what do you do? How do you actually survive this transition?
You have to fundamentally evolve your skill set. And the most prominent example of this evolution in the reports is the rise of a new discipline called vibe coding.
I know we brought this up earlier, vibe coding. It really sounds like something you do while sitting on a beanbag chair at a music festival.
It sounds totally absurd, I know. But it is a very serious fundamental shift in how software is actually built in 2026.
Explain it to me. Because traditionally, coding was all about rigid syntax, memorizing complex libraries, worrying about missing semicolons.
Right. Syntax error on line 42 and your whole application crashes. That was the old world. Vibe coding completely abandons the syntax.
So what are you doing if you aren't writing code?
You are communicating intent. It is about using natural language combined with a deep structural intuition to tell the AI exactly what to build. You aren't writing the Python scripts, you are acting as the architect.
So instead of typing out complex ifs and statements, I'm essentially talking to the AI and saying, I want a checkout button right here on the screen. And it should feel visually urgent to press. And when the user clicks it, it needs to instantly update the inventory database and send a confirmation email.
Exactly. You describe the vibe, the business function, and the user flow. You describe the what and the why. The AI agents handle the how. They write the actual syntax. Specialized tools like Cursor and Windsurf are entirely built around this workflow now.
That fundamentally shifts where the human value lies.
Completely. The value moves away from knowing how to write code and moves entirely toward knowing what needs to be built to solve a business problem.
This creates a completely new job description in the enterprise, the non-technical architect.
Yes, the non-technical architect is the hottest job title in tech right now. And it demands a totally new shape of professional. We used to talk endlessly in HR about finding T-shaped people.
T-shaped, meaning someone with deep, specialized expertise in one single area, the vertical line, and broad shell of knowledge in a few others, the horizontal line.
Right, but the AI agent changes that. Now the market demands M-shaped people.
M-shape, multiple peaks.
Exactly. Because the AI drastically lowers the barrier to entry for hard skills, you can now realistically be a world-class expert in marketing strategy and an expert in software architecture and an expert in complex data analysis.
Because you aren't doing the manual labor in any of those fields.
Right, you have multiple peaks of competency because your agentic swarm handles the tedious grunt work in every single domain. You just direct the swarm, you supervise the agents.
Okay, that sounds really empowering in theory. Be an M-shaped, non-technical architect.
It is the future of work.
But if I am listening to this on my commute right now, and I am a mid-level manager, and I am starting to panic just a little bit about my job security, give me a concrete roadmap. The report actually outlines a specific 60-day upskilling plan for professionals.
It does, and it is a very aggressive timeline, but it is necessary.
Walk us through it. What do I do in days 1 through 15?
Days 1 through 15 are dedicated purely to AI literacy, but I don't mean just reading a few tech headlines or listening to a deep dive like this one.
What do you mean then?
I mean, you have to get your hands dirty. Go into the frontier models, Opus, Gemini, GPT-5, and try to break them, push them until they fail.
We're on their limits.
Yes. Learn what the models simply cannot do yet. Learn exactly where they tend to hallucinate or drift. And simultaneously, you need to honestly assess your own current skills against what the AI can automate.
Okay, so that is the first 2 weeks, assessing the landscape. What about days 16 through 30?
This phase is called context engineering. This is the crucial graduation step from basic prompt engineering.
How is context engineering different from just writing a good prompt?
Prompting is just asking for a task. Write me a blog post about real estate. Context engineering is setting the entire environment for an agent.
Setting boundaries.
Exactly. You learn to define the specific persona the AI should adopt. You clearly define the assumptions it is allowed to make and the strict boundaries it cannot cross. You specify the exact output format you need for your downstream systems. You are essentially learning how to actively manage a digital employee rather than just talking to a chatbot.
You manage the context, not the output. Okay.
Yeah.
Days 31 through 45.
This is the execution phase, workflow automation. This is the actual test of your new skills. You have to build something real.
Build what? I don't know how to code.
You don't need to. You use visual tools like Zapier or Make or Direct APIs. You build an automated agentic workflow that actually handles a tangible part of your current job.
And what is the benchmark for success here?
The report gives a very clear metric. If you haven't built a workflow that autonomously saves you at least 5 hours of manual work every single week, by day 45, you are failing the transition.
5 hours a week. That is a highly measurable goal. And finally, the last sprint, days 46 through 60.
The final phase is entirely about evaluation. You need to transition your mindset from being a creator to being an editor-in-chief.
Because the AI is doing the creating now.
Right. You need to relentlessly develop your critical thinking skills. You have to be able to look at a complex AI-generated output, whether it is a financial model, a block of code, or a legal contract, and instantly spot the subtle logical flaws or strategic errors.
That is the new human edge.
It is the only human edge left. The AI can generate infinite content and perform complex reasoning loops, but it fundamentally cannot discern human truth or qualitative value the way a seasoned professional can. Your judgment is your job security.
To pull all of this off, the report notes that you need a new tech stack. You can't just rely on Microsoft Word in your email inbox anymore.
No, you need a personal productivity stack built for agents.
Break down the 3 pillars of that stack for us.
First, you need an idea hub, a place for raw brainstorming and research. You should be using a tool like Perplexity or a deep reasoning model for this, not just standard Google search.
Okay, an idea hub.
Second, you need a knowledge hub, a central brain to organize and synthesize all those ideas, something like Notion AI, where your notes can literally organize themselves and connect concepts automatically.
And the third pillar.
The execution hub, where the actual work gets produced. If you are doing vibe coding, that is Cursor. If you're doing visual design, that is the agentic version of Canva. The key skill is becoming entirely comfortable seamlessly moving context and data between these 3 hubs.
It really feels like we are standing at a major tipping point in modern work history. The report actually calls 2026 the year of the agentic divide.
The agentic divide, that is the perfect summary of everything we've discussed today.
It is the growing gap between the people and companies who still treat AI as a passive tool, like a very smart calculator, and the people who treat it as an autonomous colleague.
And that gap is widening exponentially every single day. Look at the data we covered. The hardware is completely ready. The Rubin platform is pushing 50 petaflops. The models are ready. Opus is solving complex software bugs autonomously. The plumbing, MCP, is fully standardized.
So what is holding us back?
The bottleneck is no longer the silicon chips or the software algorithms. The bottleneck is us. It is purely human adaptability. It is our organizational courage, or lack thereof, to completely change how we structure a workday.
Before we sign off today, I want to leave the listener with one final, slightly provocative thought drawn from the source material. We touched briefly on sovereign AI earlier.
Yes, the Alibaba Quen model.
Right. Gartner makes a stark prediction in these reports that by 2027, 35% of countries globally will have entirely region-specific AI platforms. We're seeing the rapid rise of digital protectionism.
The splinter net of intelligence.
Exactly, the splinter net. So let me pose this scenario to you. What happens in the very near future when my automated supply chain agent, based in Chicago, needs to aggressively negotiate a parts contract with a supplier's autonomous agent based in Shanghai?
It's a great question.
But the Shanghai agent is running on a state-mandated Chinese sovereign model that, due to geopolitical trade restrictions, is legally not allowed to directly interface via MCP with my US-based model. What happens to global trade then?
That is the multi-trillion-dollar question keeping tech CEOs awake at night right now. We might literally be heading toward a fractured world where your software needs a digital passport just to run an API call across a border.
A passport for your software agent.
Yes. A world where we have massive international trade wars, not over physical steel or agricultural tariffs, but over inference tokens and proprietary model weights.
That is a wild, incredibly complex world to imagine, and it feels like it is right around the corner.
It is already starting, but we honestly can't solve global geopolitical trade policy today.
No, we cannot. So what is the immediate takeaway for the individual listener right now?
The takeaway is incredibly simple. Stop playing, stop treating this technology like a fun novelty or a weekend sandbox experiment. You need to start hiring your AI.
Hiring it.
Yes. Give it a formal job description. Give it a specific, bounded workflow, and actually hold it accountable for producing real, measurable results.
Because if you don't hire it to do the work, your closest competitor absolutely is going to.
Precisely. The future-built firms are already doing it.
Well, that is it for this week's Deep Dive. We have covered the staggering hardware capex, the specialized model ecosystem, the agentic architecture patterns, and the massive career shift awaiting all of us. It's a lot to process, but that is exactly why we are here to break it down. Thanks for listening, and we will see you in the future.